Okay, this is a xenon spectrometer. So this is the light source, and we have one fiber that is connected to the probe, and we have another probe coming from the reflection mode to the detector. So this is detector. It is connected to two fibers. One is source, the other is detector. So we have a couple of slit sizes. So with the color, you're seeing the slit sizes. We need one of them with a red color for absorption spectrometer. The other one is blue with 200 micrometer for photoluminescence. So we gotta make sure that every time that we are measuring, we switch, either use this red one or blue one. And in between, if we have a different material, we can use the other slit sizes to fit the background with the sizes that here we have. So once we connected this slit to the end of probe, we can attach it. There's a crack here, so we gotta match the crack with this point over here to connect the probe to the detector. If you flip it, you're not gonna be able to do it. Once it is matched, we can measure. So here we have Avantage software that we can go through it and measure something. So here you're seeing there are a bunch of options like a scope mode, a scope dark mode, minus dark mode, absorption and transmission. So for absorption, we need to click on this. Once it is clicked, we need to take the background with one of the substrates without film, like this. So I'm gonna put the probe on top and click on start. Once it is measuring, let me go to the new window. So this is the spectrum new window. So once you are starting, you need to click on this guy, save reference spectrum, and accept it. Then we need to turn off the xenon lamp. Can you come over here? So if you click it on up, it's gonna be off. Right now I can save the dark mode. Again, I clicked start. This is the dark mode. There is no light coming out, and I'm just measuring whatever as in the ambient. Once it is jiggling, I can save the reference as a dark mode. So this is ready to measure any film. So again, I need to turn on the xenon lamp. For example, let me have one of my samples here. Just a second. So since we measured this blank substrate here, and we saved the blank area with this substrate, so I'm gonna put this new one that I want to measure it in exactly in the same place, and put the probe on top and start. So here I'm seeing the absorption spectrum that has one edge here. Once it is ready, I can transfer it to the Excel file. So for that, I gotta go to the file, export, and Excel new file. Once I clicked it, the last one is the spectrum of the absorption. If I want to plot it, I can easily plot it and measure the talk plot and cutoff wavelengths from this point, or I can easily see the logarithm scale of that, and this is our band gap, and the slope is Verbeck energy. So everything is ready to measure. This is the filter. We need to have a very narrow part of the xenon spectrum. So here I'm opening this input and attaching this filter here to do filtration of the broad spectrum of xenon. Right now we have a profile of 410 nanometer central wavelengths with a full width half maximum of 20 nanometer. And then again we need to switch it, the slit, from red one to the blue one. And again we need to flip the crack down to match with the detector's probe. Once we did this, again we need to change the setup. Okay, for photoluminescence we need to go to the scope mode with the minus dark mode. So there are two scope modes. This is scope minus dark mode. Once we clicked it, we need to connect this filter to the input and then switch the slit sizes to the blue one with the 200 micrometer here in the inputs of the detector. Then we need a mirror and one blank sample and the substrate that we want to measure. Then we put the probe on backside of the ITO and click on this. This is dark mode. I'm going to save it. Then turning on xenon lamp. The same condition, clicking and starting, save it as a on mode. So we have a huge pulse from the ambient air. It's better to turn off the light for photoluminescence measurement, but here is just a tutorial. Once it is ready, the background is saved, we can switch the probe to the sample that we want to measure. We gotta make sure that it is completely attached, otherwise it's gonna scatter the light, and then measure the photoluminescence. So here you see the photoluminescent peaks up here on 740 nanometer and 2800 counts. Again, if we want to transfer it to the files, we can go to the file and Excel, the last new Excel file is our file. We can easily plot it. To save the data regularly, we can go to the options here and go to the save it spectra periodically and choose how often we can save. So once we selected 1 second, it's gonna save the spectra every 1 second. And there is a delay between scanning. It is giving you a time to put the probe on the sample and then it starts to measure and save it. And here is the path that you want to save the data. And again, if you want to change it quickly by one of these items, you can go here and choose how often in terms of millisecond you want to save it, and this is the path that you need to save, and the delay is here 0. You can switch to any numbers that you want. But for photoluminescence, since we are giving 2 seconds, it should be logically every 2 seconds or so. But for absorption, we need to save the data every 200-300 milliseconds, because for absorption, if you remember, we took this 20 millisecond and 50 averaging. So it may take kind of around 300-400 milliseconds to save each spectra. And if we are doing high throughput experiment, there are a huge number of data that we need to transfer. So the last one is not our data. For that, we need to go to the file and convert file to Excel, then choose the path that we already gave it. For example, Avantage. Here we have two files, select it and open it.